bei Vision.A. Zwei spannende Vorträge haben wir schon gehört. Jetzt sind uns live aus Ungarn zugeschaltet Kristof Szabo und sein Kollege Zoltan Kovacs. Sie sind von der Firma Deep Fake. Und wer gestern schon einen Auftakt hier mitgenommen hat, der hat sie schon indirekt erlebt, nämlich in dem Deep Fake zu Angela Merkel, den sie gemacht haben. Und genau das ist die Aufgabe von Deep Fake, beziehungsweise eigentlich das Gegenteil davon, nämlich solche Täuschungen zu enttarnen und mit ihrem System Fakten von Fiktion zu unterscheiden. Das Ziel ist es, wir haben es gerade sehr gut die Überleitung gehabt von einem anderen Vortrag, das Ziel ist es, die Medien zu verbessern, Fake News zu verhindern und einfach da für Klarheit zu sorgen. Eine kleine Warnung, der Vortrag, der jetzt kommt, ist auf Englisch. Sie können aber trotzdem gerne Ihre Fragen auf Deutsch weiter in den Chat stellen. Wir übersetzen das dann für Sie und geben das an Kristof weiter. Mit Muttis Worten, wir schaffen das schon. Kristof und Zoltan, nice to have you here and stage is yours.
Thank you very much. Hello, everyone. I'm Kristof, one of the co-founders of Deep Fake, and I have my other co-founder, Zoltan, who is filling the role of CTO at Deep Fake. So Deep Fake was founded over a year ago in Copenhagen, but in November, we moved our headquarters to Berlin and have been there since. In the next 20 minutes or so, I will try to distill you all my knowledge that I collected in the last 1.5 years about deepfakes and really give you an overall idea of what this technology is capable of and where we see it going in the next few years. So in this presentation, I will shortly tell you about the general idea of deepfakes and the definitions, then how we create these videos, then how we detect it and actually work against them at Deep Fake. And in the end, we will talk a little bit about the general authenticity of content as we know it today in our digital world. So when we talk about deepfakes, we have to mention 2016 and the United States election, and we have to talk about fake news. And what I recognize in 2018, that combining this AI and machine learning based technology with the power of social media, we will see something even bigger, even potentially more dangerous for democracies and societies in the 2020 elections that is coming up in a few months. A little bit about the timing itself. 2020 is the year where the general advancement of AI and machine learning technology reached a level where social media can boost it and generating these kind of fake content reach millions, if not billions of people. I won't go into detail on the technology side, but in general, you have to know that computing power, such as CPU, GPU, is reaching an extreme level, which can support very high computation, and in general, can create these videos almost real time. A little bit about the general idea of deepfakes. So first, this slide seems very confusing, a lot of moving parts, and I tried to just distill the most basic definitions and the most basic types of these deepfake videos that you have to know about. So if we start on the left side, everybody knows Photoshop. We have all seen some examples of how images can be manipulated with this Photoshop technology, how they can be misleading, sometimes in a funny way, sometimes in dangerous ways. In the last year, we have seen many examples for these kind of images in the media and how they can affect these large media organizations, how these can mislead millions of people on Facebook and other social media platforms. Now imagine this multiplied by the power of video and how we believe that video is something, a recording of something that happened and that, has happened, and that's an evidence of that something happened. Well, not anymore. Now we can manipulate videos in ways that we can basically, have Trump, have dead presidents of the United States, like you see in the right upper corner, Nixon, say anything that you want them to say. So in this particular video that I show here of Nixon, he is actually announcing that the moon landing was unsuccessful. This was created by researchers, and it's actually, you can imagine what are the implications when we can, make anyone say anything that we want them to say and then spread it on social media and in media. Maybe, Trump announcing a nuclear war or Merkel announcing a recession in Germany. On the other side, we see an example of a cheap fake, and this is something much easier to create. In this example, we see Nancy Pelosi, who is a Democrat and a high level politician in the United States being on this video as if she was drunk. This video was actually shared by Donald Trump on his social media profiles, and many people were misled by thinking that Nancy Pelosi was drunk on this video. And of course, you can imagine the consequences and the effect of such videos. We also know so-called audio deepfakes, and in general, we use the deepfake term now pretty much for anything that is fake and a video. But in the case of audio deepfakes, we can, for example, have a high position CEO say something about the company, maybe on the phone, maybe on the radio, that can eventually affect stock prices, but maybe people will lose jobs because of this announcement that was actually faked. So a little bit about the generation from our CTO, Zoltan, so that you will have a better idea of what kind of efforts you need to create these videos.
Thank you. So now I would like to talk a bit about the technology behind all of this deepfake generation. And without going that much into the details, I would like to share that, as Kristof has mentioned, there are different types of manipulations, but essentially they are all created with the same technology or the modification of the same technology, which is generative networks. And generative models are a sub-branch of deep learning, where they not only learn patterns through training, but they learn how to create new data that is similar to the data that they seen during the training process. And on the left-hand side, you can see this figure that shows how the autoencoder, one of the most commonly used generator, is working. And an autoencoder is made up of two parts, an encoder and a decoder. And the encoder takes an image as an input, and it basically does a dimensionality reduction. So it reduces the number of dimensions that this image or picture is described in. It creates a more simple representation of it that we call a latent representation. And then the task of the decoder is to map from this simple representation to an image which should be as similar to the original one as possible. So basically throughout the training, the point is to reduce the differences to reduce the differences between this generated image and the original image. And this loss is minimized during the training. And so far, it's basically a compression scenario that the original image is compressed to a smaller, more simple representation, and then it's decompressed to an original, authentic, realistic image. How can we use this technology to create deepfakes? We can use a simple trick by training two of these autoencoders, one for a source image and one for a target image, as shown in the figure. And they share the same encoder. So this encoder learns how to extract the most basic facial expressions and facial structures of the two faces, while the individual decoders learn the individual facial structures of the humans, the two different faces. So they are specific to the source image or the target image. And for inference, we can swap the decoders. So we can take the source image and extract the facial expressions, and then use the decoder to predict the texture of it. So it will look like as the target, but it will have the facial expressions of the sources. And then we can just crop the image part and paste it into the video that we wanted. This is something that we call a face swap. Another important generative model is GAN, which stands for Generative Adversarial Network, where we have two networks competing with each other during the training phase, a generator and a discriminator. The task of the generator is to create realistic looking data points to fool the discriminator, and the point of the discriminator is to figure out which one was created by the generator and which image was actually authentic. So during training, they compete with each other, and this makes them better with performing their own individual tasks. And on the right-hand side, you can see some of our results for a deep video portrait. The difference between a face swap and a deep video portrait is that in a deep video portrait, the faces are not actually exchanged, so the visual integrity of the output is higher. And here, the target video is only used to drive the face of the source image. And you can see that still it's capable of translating the facial expressions from one person to another one. And you might think that this technology is so complicated, it might only be accessible for educated scientists or universities, but it's actually not true. Most of the research is coming from the community. That means that enthusiastic amateurs with good computer skills are building these models, and they share their knowledge on GitHub, for example. The two most famous deepfake creator tools are openly available on GitHub, and they are continuously updated. And from time to time, new mobile applications appear where you can create your own deepfake. And there has been a big scandal around the Chinese app called Zao in 2019, because after a few weeks of their operations, it turned out that they basically stole their users' data. And as you can see, this is another threat when it comes to deepfakes. And talking about the threats, there should be some ways to detect these videos. And I like to say that deepfake detection is a cat and mouse game, much like the whole world of viruses and antivirus softwares, where there's no guarantee that the currently best detection tool is going to stay here for another half a year. Both the creators and the detectors are continuously developing their own technology, and much of the development on the detection side is coming from the Kaggle Deepfake Detection Challenge, which has ended this March, and it was made by the cooperation of Facebook, Microsoft, Amazon, the Media Steering Committee of the Partnership of AI. They committed $10 million to create the biggest deepfake dataset ever, comprising 100,000 manipulated videos, and more than 2,000 teams have participated. And this just resulted in a big push on the technology of deepfake detection. So I believe the detectors are one step ahead as of now, but of course they continuously need to innovate to stay in game. And at Defudger, we are not only specialized in detecting deepfakes, but we also detect manipulated images, since they are a problem. Even though the problem has been around for a long, long time, there is no conclusive solution for that. And what we do is that since image manipulation can be of many different types, similarly to deepfake videos, we cannot just have one single algorithm that's good for detecting all kinds of manipulations, but we have specialized individual algorithms to detect certain signs of manipulations, and then we combine their results to have an overall final result. And some of these individual algorithms focus on very simple telltale signs, such as the metadata, inconsistencies within the metadata, or we do reverse image search, looking for the exact copy of the image if it has ever appeared online. Then we have the more interesting algorithms based on machine learning and computer vision that take a look at the pixel level of the image, and they look for inconsistencies there. And these inconsistencies might not be visible by the human eye, but these advanced algorithms can detect changes in the noise levels or different JPEG quantizations. Then we combine the results of these individual algorithms through ensembling, and that outputs a final heat map that shows the manipulated regions, and it also outputs a percentage of what's the likelihood that the input image was manipulated. Moving on to the videos, the deepfake videos, we use a similar approach of combining different models. where the overall idea is to do a per frame binary detection on the video, meaning that we extract individual frames from the video, and then we do a face tracking. We extract the face region of the video and then input those images into convolutional neural networks that carry out the classification. They decide if the input image is actually authentic or manipulated. And here we use a weakly supervised data augmentation network to highlight some of the regions that are more valuable when it comes to differentiating between authentic and forged content. And then we have a similar ensemble method to combine their results and have an overall output. And here you can see the result of our algorithms. You can see that we do the per frame detection. So for every frame, we have a score. What is the percentage that, like, what's the likelihood that the included face is fake or not? And it might not be visible for the human eye to see that one of the characters is fake and the other one is not. And besides active detection, we also do research into passive detection. That's something that we call authentication, where we make sure from the moment of creation that the content is not modified. And this technology can be useful for many different industries. For example, in the news media and publishing, we can use it to track images that are coming from freelancers or third party that are not the actual reporters of the news organization. Or in the insurance industry, it could be used to settle claims, because the claimant could take a photo in a safe capture environment of the damage that they have, and then they can just send this photo over a safe channel to the insurer, and the insurer will make sure that this could be used as evidence. But then it has many other use cases in other industries, such as cybersecurity or KYC. And what our solution is about is to create this overall pipeline for an end-to-end verification, where the image or video is captured in a safe environment, where not only the visual content is safe, but extra information about the location, the time of capturing, maybe cellular data is saved. Then this whole package of information is sent to an authentication server, where we use our detection algorithms to look for inconsistencies. And if everything is fine, then we conclude that this data can be trusted, and we extract hashes from it to be stored on the blockchain for future references. And we could optionally embed an invisible watermark to track where that image is gonna go on the internet later on. And a very interesting aspect of this whole authentication is something that has risen over the COVID-19 quarantine, that many people turn to telemedicine and telehealth when it comes to medical consultation instead of visiting the doctors in person. And when it comes to such a high stakes decision, so important things such as the well-being of a person, you really need to be sure that you are actually talking to the person, you're actually talking to your doctor, and it's not a deep fake of your doctor, or it's not just somebody who's impersonating it or hijacking the video call. And for that, we are developing a solution for end-to-end encryption and authentication of both parties participating in a video call.
Thank you. And now, just to really close the presentation, I want to tell you a little bit about what we are actually working on right now. So as I mentioned, we are a startup, and we have started to work with media companies, especially focusing on image manipulation detection. And for that, we provide our web suite, which is a simple web app where journalists, fact checkers, anyone working with content at these media companies can upload an image, and then they can get a detailed report. We do the same in a form of an API, which can be directly integrated into their data flow, so that we automatically check all the images that are incoming to the publisher. This is what it looks like right now. So this is our beta app that we have tested with some German media companies. So you can see they upload an image, and then they get a very simple breakdown of how likely the image is that it has been manipulated. And then we also show it on a heat map. We have also a very detailed report that could be several pages, just detailing details on the metadata, on reverse image finds, on different modifications that happened on the image, which might take up to a few hours for a journalist, but we do it within a few minutes. We have worked with some of the largest German media companies. As I mentioned, we participated in the Axel Springer Accelerator in Berlin. And currently, we are working more on the authentication side to also be able to serve other industries, such as the insurance or the medical industry. And we are conducting currently research in many of the fields with deepfake detection, and to be ready for once we will see deepfakes on social media. Maybe it will happen during the elections. Maybe it will happen in 2 or 3 years, but we hope to be there to be able to detect deepfakes and really serve the people and defend our media and transparency. And just to give you an idea of what dangers actually there are, this is a video from a few weeks back when somebody joined a Zoom call disguised as Elon Musk. And here it's bad quality, but you can see it's already pretty advanced. And especially with sound, it could be pretty convincing, especially if it's a person that you maybe only seen in a picture. And relying on the quality of these kind of video calls, you can easily trick people into believing that you are someone else. This gives you an idea of some of the known pictures turned into a deepfake. So this is a one picture based method where one picture is turned into a deepfake based on your facial movement. As you see, it's not a very complicated code. You can basically download it from GitLab or GitHub, and you can run it on your computer in a few hours if you know a little bit of Python and coding. So I believe that we will see more and more of this technology coming into our daily life, like maybe media, hopefully in movies, not on social media necessarily. And hopefully the Fudger will be there to serve the media and other industries. Thank you for your attention. And if you have any questions, then please feel free to ask. And we will be also available after the sessions in the networking event to answer any of your questions.
Okay, Kristof and Zoltan, thank you very much for the really, really interesting insights you gave us. Frightening, but still very interesting.